This is the x-axis. All of these y values are equal to 0. That's what we're saying, is that every y value is equal to 0. Doesn't matter what the x is, the y value is 0 there. So when we say it's increasing, that's the domain that it's increasing on, but I don't want you to think that the y is negative infinity. The y is starting out close to 0. It never actually hits 0, but it starts at 0. Now going back to what DJ said earlier, if it's increasing, is it a growth or a decay? Growth. Thank you. That's what we needed to see. The fact that it's increasing tells me it's a growth. That's the most important part. So what do we know? Okay, so the what's greater than 1? Come on, we're almost there. What's got to be greater than 1?
The base.
The base. Thank you. So, I know that the base has to be greater than 1. Based on the reference point, any guesses what the base should be?
6.
So let's check. So let's check. 6 raised to the x. What is 6 raised to the first?
6.
So, would that be the x value 1, the y value 6? So does that work? Okay. That is one option. And please hear me very clearly on that. That is an option. We're not going to get into all the different specifics, but there are other ways that we could do this. For example, I could have done y equals 2 times 3 to the x. We haven't looked at what are called transformations yet. We will soon. But notice this is also an option because what is 2 times 3 to the first? 6. So that's another exponential equation that would get that reference point. It would also be increasing because it's an exponential growth. The only reason I bring that up is this: ask yourself over here, do you have enough information to write a unique exponential function? Meaning that there's only one option. No, there's multiple. There will always be multiple. Unless more information is given. So Cameron, what do we know for b, the fact that it's decreasing over negative infinity to infinity? What's under 1? What number? Come on, we need to use more specific with our language. What has to be less than 1? There we go. Base has to be less than 1. Kyla, why is Cameron thinking that the base has to be less than 1? There's one idea that she kind of skipped over. Say again? Why do we know it's decaying? Say again? Because it's decreasing, right? That's the whole thing, is we need to recognize, and you jump to that, the fact that the base is less than 1, but it's because it's decreasing, we know it's decaying, we know the base has to be less than 1. There's lots of options, but any guesses, and so we'd say decay here, any guesses about an equation that we might be able to use based on this reference point? So, well, it'd be 4 raised to the x, and then we would have to substitute the negative 1 in to see if that works. What do y'all think? No? 4 is not less than 1. Would that be a decay? That'd be a growth.
It's a negative 1 to the x.
You're closer with the 0.4, but remember,
0.04.
not 0.04. I thought I heard someone saying it. Huh? 1/4. Which is kind of why you're thinking 0.4 is my guess, but remember that'd be 0.25. 1/4. Because remember, what does a negative exponent tell you to do, or what is it going to do to that number? It's going to tell you to divide, right? So if I do y equals 1/4 to the negative 1, then I'm just going to get the reciprocal, which is 4. Right? A negative exponent tells you to divide or gives a reciprocal, so that's what we get.
What would the graph look like?
Well, what point do all these functions have in common?
negative infinity and positive?
That's not a point.
Or you mean negative one?
No, that's not a point.
Oh, no, well, not, they don't look like they have anything in common.
They all have 1 point in common. Not just a 1, because that's not a point. 0, comma, 1. Right? They all have that 0, comma, 1. Because what's anything raised to the 0? 1. And then what's 1/4 to the 1? 1/4. That's one that should just jump out, right? Anything raised to the 1 is that thing, right? 1/4 to the 1 is just 1/4. So it would look something like this. Because I know it has that horizontal asymptote again of y equals 0. CD, it doesn't tell us on C that it's increasing or decreasing, but it gives us in behavior. What do you think that in behavior is telling us? Do you think it's increasing or decreasing?
Increasing.
Why?
Positive feelings. And it said as a, oh, never mind, as negative feelings, as a goes from negative feelings to 0.
So as x goes to negative infinity, my y is going towards 0. Okay?
So I think it's
So you think it's increasing?
going to 0.
So it's going to 0 on the left-hand side, but on the right-hand side, right-hand in behavior, what's it doing?
Going to all positive feelings.
So it's going up, down, up, so increasing. Anybody want to push back on that, or do we agree? And so at least go ahead and make a note here of growth. Says every time we are significantly behind. I need you to try to fill out this table. We're going to start by going over this table and answering any questions that you have. But use your 6 graphs that you already have done to help you fill out this table. You should already have this no matter whether you have your textbook or not. That I'm going to add on to the homework. So that's the table on N3-110. Remember, I will not see you tomorrow, so you need to have this ready for Thursday. Hold on 1 second. Yeah, that's what I was going to say. I need it for my 4th block, so I need you to come by after 4th block.
I'm probably
Hold on. Yeah, you can. Tuesday, December. What is Tuesday? What are we doing? The 7th?
No, it's just
So please notice I am updating this. That table should not take long, but I need you to have that table ready when you come into class because I will be expecting it done. If it's not done, then you will unfortunately probably be a little bit further behind than you want to be and confused at times. So, the characteristics of polynomial function skills practice is due on Thursday. That table is due on Thursday as well. This practice, it's only 2 problems, will not be due until next Tuesday. Friday, we're going to have that individual understanding check on analyzing polynomial functions. As you noticed, hopefully today, will some of the features show up within this unit to help? Yes, but we've got to get going on it.
So they made us do test corrections again on this one too? Well, I'm not even finished with my last one.
That is problematic.
Hopefully this time it'll be better, like since I have a calculator. It was
Yeah.
bad. When yours
Yeah.
was bad, I had a lot of math in there.
Have a good rest of your day, LeShannon.
Did you watch the game last Saturday?
Do you mean did I stress out like a champion
Dude,
last Saturday?
Me and my parents were, dude, it was awful. I don't know how we won, but
Yeah, same.